Welcome back, everybody. Welcome back to the channel. So today we're going to pick up where we left off and continue talking about parsing expressions. So before we get into that, quick few housekeeping things. I added some new stuff to the actual compiler. So here I'm going to go to our tokenizer here, tokenizer, and I basically added what's called a power or an exponent character. Basically allows you to get the exponent of a number. So like if you guys have ever learned in math class, where they say like something to the power of something else, that's basically what that means. So you guys are going to want to add this. This is actually very important for a feature that's going to be added, or that I'm going to show you guys in the next episode, which is going to be on Friday, I believe, right? Is that going to be? Yes. Yeah, that's going to be on Friday because today's Wednesday. Filming this video like super late. Um, so yeah, that's going to be for Friday, so definitely add that in. So all it consists of is two multiplication symbols, and I created this exponent and the token type here. So you're going to want to create this exponent enum, and then in the tokenizer, when we check to see what symbol it is, I have two parts of this. I have like the part where I check to see if it's a double symbol, and then I have the after part where I check to see if it's a single symbol. In this case, it is two multiplication signs, so it is a double symbol. So yeah, so exponent. So definitely add that. And then once you add that here, you're going to want to go to the parser and add that into, let's see if I do a search for that. You want to add that in the override operator. So this is optional, completely optional. You don't have to do this. Um, but I thought that, I don't know, maybe if you have like a class and you want to use this exponent operator, then you should be able to do that. But yeah, so that's pretty much it for that. And now let's get into what we were originally going to be talking about today, parse expression. So now, like, we've went over a bunch of things, right? So I've shown you how to build an expression. We've went over like some of the things that go, or the one thing that goes before primary expressions. That's for plus plus and minus minus. So that is a pre-increment expression. Then we went over our primary expressions, and now we're getting pretty close to being done. So we got just a few more things. Um, so what we're going to be doing today is I'm going to be showing you guys how to basically process a dictionary, and then how to process assign expression. So how do you like assign variables and stuff? So first, let's look at this one here with the left curly. So this is kind of a twofold thing. Now, you guys know in my language, I have basically multiple ways of using the left curly brace. It can be used for blocks, it can be used for arrays, or it can be used for a new array, like the creating a new class, and then you say you want to initialize that class basically in line. But now we also have another way, which will be consisting of anonymous arrays and dictionaries. So let's just see how it looks. So we check to see if the next token is equal to a left curly, and if so, we enter protected mode because this one, like, it's going to depend on which one we're processing. It's either going to be a vector expression or a dictionary expression. So we check to see, and we're going to go with the vector expression first because that's a little bit of a simpler concept. So first you want to enter protected mode. Of course, you want to store the current token, so that way you can reset it for later. You want to advance one token, so that way you can consume this left curly here. And then after that, there's going to be a format. So for dictionaries, there's going to be basically, let's say we have dictionary here. Okay, right. So if we have a dictionary, and let's say we want to create, I don't know, a dictionary of numbers, the format for figuring out at the parser level which is which, we'd basically just look for, some expression, so like 200, and then if there's like this symbol here. So if this symbol is immediately after the expression, we know it's in fact a dictionary. Otherwise, if there was like an as symbol at the start of the dictionary, we know it's also a dictionary because this allows us to specify the type and say like string, or better yet, int string. If we want like a int and then a string, then the 200 could be the int and the string could be hello, or whatever, just whatever the message will be. So that's going to be the format for dictionary. For vector arrays, that will consist of, and I mean, this is what makes it a little complicated. You have like your expression and then, some other value. Now, vector arrays on the parser side, there's no bounds or rules to what you can put in here. But on the back end, we just want to make sure that the user isn't putting like random types in here, like they all need to match. So you can't mix integers with strings because that doesn't make any sense. So ideally, in this case, they would have like multiple um, ints or something like that. So it looks something like this. So if we go back to the parser, this is for dictionary. Okay, so if the next token is not equal to a like this symbol here, so like here, I also forgot to mention something. So for dictionaries, it's entirely possible that you have a completely empty dictionary. It's like if you just did something like this, right? Obviously, like there's no values in here, but you can basically create an empty dictionary by denoting that little symbol there. So that will allow us to do that. So we want to check for that, or like I said, we want to check for as, so that way we can specify what the type of the dictionary should be. Otherwise, we parse an expression like we just saw, and then we check to see if the next token is equal to this token right here. And if so, then we want to reset the current token to its old value, ignore any errors, and then free up the last sub because, of course, this is going to create a sub AST. And then we want to parse a dictionary expression. So we have the case where we have, nothing, or the case where we have the expression, which would be 200. And then, in this case, the parser wouldn't actually go to process this yet. That would get processed in parse dictionary, but we want to basically just roll back to this point and then process it in the parse dictionary function. Otherwise, if it's none of that, then we basically assume it's going to be a vector array, so we parse a vector array. So we do basically the same thing, um, and even though this code is like copied, you need like this code to be like you need after you process this to check what the next token is. So you can't immediately just like put this code after parse expression because you need to check to see if the next token is equal to this. If so, then you have this code. Otherwise, you write the same code. But let's look at parsing a vector array. So we're going to basically pass the AST of get branch vector array directly into it. So the AST that's parsed into, oh, is that, oh, okay. So I guess that makes sense. So what you want to do is you want to encapsulate this vector array into a AST vect underscore E, which basically denotes it's a vector expression. And of course, you want to use the branch. That way it's nested properly under the AST. And then when you get into here, we're going to create a branch called AST vector array. And we are going to expect basically the left curly. And then, of course, after that, we want to do the same stuff that we do everywhere else. It's just basically a list of expressions. So, and I actually think, like, can I use a function? What is it called? Parse expression list? Yes, I actually can, but I think this function, yep, okay, so do not do that. That makes sense. So yeah, so we basically just do the same thing that we do everywhere else. We basically check to see if the next token is equal to a right curly. If so, parse an expression. If the next token is a comma, consume that expression or consume that comma. Do not need this, so we can say false. We don't need to add it to the AST. And then we parse the next expression, go back up to the top, rinse and repeat. After that, we parse our ending curly brace, denoting this is the end of the vector array, and that's it. So let's look at the case where we have our dictionary. So in our dictionary, it's roughly the same stuff, except dictionary is a little bit more interesting. So you have your branch of a dictionary array, and then you have your left curly that denoting that you want to start the dictionary, and then you have parsing a dictionary type. So this is that as portion I was talking about. So you basically check to see if the next token is equal to as, and considering that this is not necessarily required, we want to check to see if the next token is equal to as. If it's not, totally fine, we just keep going as we are. Otherwise, we create a new branch called AST dictionary type. We expect the as token. Do not need that. So we check the as token, we check the less than symbol, which denotes like this is the start of the type. So we want to basically check the first type and then the second type. So we don't need actually any of these characters. So I'm just going to put false on all of them. And yeah, so we just want to parse two U types inside of these less than and greater than symbols, and that will result in the type of our dictionary. All right, so I made some changes. Basically, what we want to do is after we parse our dictionary type, we want to check to see if the next token is equal to colon. Now, if you guys remember, we can simply just have a blank dictionary. So if the next token is not equal to a colon, that must mean we have like, something here because obviously we've already processed whether or not we have an as. So if after that as we have, because like it's perfectly legal for you to have like, let's say as int comma string, right? So you want to create a dictionary of type int and string, but it's a completely empty dictionary, and that's totally fine. We can modify it after the fact, but in this case, whether or not it is, we will support that. So we want to check to see if the next token is not equal to a colon, and if so, then we want to parse what's called a dictionary element. And up here, that's what this is. So it's parsing a dictionary element. Made a mistake. Element. All right. So a dictionary element basically consists of an expression, a colon, and another expression. So I'm going to say false here. We don't need that token as well. But yeah, so that's pretty much what that is. And you guys know what this is. We do the same thing everywhere else. We parse our thing that we want to parse. We check to see if there is a comma, expect the comma. We also do not need the comma here. And we parse the thing we need to parse again, and we go up to the top, rinse and repeat. After that, we basically expect our ending curly brace here, and that denotes that we are at the end of the dictionary. Now, dictionaries are technically classes in my language. So, like when we get to the back end side of everything, we're going to be creating this dictionary class. And this expression, right, this high level construct of creating, or this rather, this high level construct of creating this dictionary using syntax will effectively return a class. So we need to basically you know, have like a dot here so that way we can like access functions or fields inside of there and do whatever we need to do. We can also do plus plus or minus minus. And we also want to support some other things. So I'm going to go ahead and add more support for dictionaries and come back after that. All right, so I have updated everything. Basically, all of this code is exactly taken from the parse dot notation call expression. And what it allows us to do is treat this dictionary as a dot notation call expression because technically it is. So we want to allow the user to increment and decrement. We want to allow the user to use the left brace. So like let's say they create a dictionary. Now this is extremely inefficient to do this, but let's say they create some dictionary and I don't know. So I'm going to have this example here. So 200 and then let's say hello. And let's say they then say at 0, right? So they say at index of 0, or more specifically, at index of 200, because this would be the type of dictionary that you are creating. So we could say at 200, and that would effectively return the hello value from this array here, because of course the dictionary class would basically create an operator overload for the array symbol, and you pass in the value of what data is the key for that dictionary. So I know it's a bit complicated. We will get into how that works later on. There's a pretty simple solution for it. But we want to support left brace, so that's what that's for. We also want to support dots and literally every other wacky thing that we've already gone over this. So, I mean, literally, I just exactly copied this increment check with the exception of this comment here. I basically copied from increment check all the way down to the last else statement and pasted that inside of parse dictionary expression. So you guys don't really have to do much on this front. If you guys follow my YouTube series, just copy paste it and you'll be fine. So once we do all of that, let's go back up to parse dictionary expression. and we can see that's pretty much it. So if we have the case where it's an empty or it's an as, we've already seen this. We just fail the errors and then decrement the current token. You want to make sure that the current token is in a pre-state, like meaning that the current token it's before what you need to actually process. So if we start with the left curly, then you want to put the character before that. So when you guys are writing your parser, this is one thing that I want to say that's like an easy bug that I always trap myself in, where I'm not realizing what is the state of context that the function is processing. Meaning that, like, is your function expecting that the current token is what it's processing, or is it expecting that the next token is what it needs to process? Kind of like how parse expression works. So just keep that in mind when you're writing your parser. After that, we return true, and that's pretty much it. So let's see a sign expression. So this is going to be grammar, and we're getting very close, guys. We're getting pretty close to finishing up everything. So that represents this here, so this code. So next episode is going to be how to process math expressions or arithmetic expressions. That's going to be a ton of fun, and I got some interesting stuff for that video. But today we just want to make sure we can have other expressions assign each other values. So if we go back to the where is the part? Okay. So if we go back to the parser, all we want to do is just check to see if the token is an assign expression symbol. Now, this is exactly why I mentioned when we had our override operators, you want to split out this function as assign expression symbol because you want to use this in a different spot. So this allows us to have specifically symbols that are or tokens that are used for the explicit purpose of assigning values to something else. So we have, of course, our standard assign, and then what this is called on the back end is this is basically called a compound assignment, which basically just allows us to do multiple things. So like not only are we assigning like a variable a value, we're also adding that value. So plus gets would, instead of just saying x is equal to y, it would be x is equal to x plus y. So it does a little bit more work. So in order to support that, I'm going to just do a find here so we can go back to where we were. When we have our sign expression symbols, of course, if it's the next token, we advance, we add that token. Very important, we need to process and contain this token inside of this branch because we'll need to know which assign expression symbol we were using on the back end. After that, you want to create a write AST, and you basically want to just create like an expression and put that under the write AST. Now, why I didn't just use git branch, I have no idea. I think this is code that's just copy and pasted from my old parser. Ideally, what you do is you just call git branch branch ast underscore assign e as your write expression, and then just put this expression or pass that branch into this function, so that way it goes under this or under the appropriate AST. So I know this looks kind of ugly, but it works, so I'm not going to touch it. But yeah, so after you do that, you want to check to see if the next token is not an expression symbol. And what that basically is that is like a math expression. Now, I mean, I know I have like this here. We're not going to really be processing that. We've already kind of processed that inside of the primary expression, so we don't have to worry about that. But all of this other stuff, like plus plus, minus minus, or actually probably not even those, pretty much everything from the multiplication symbol down is something we could potentially process. So if the next token is not equal to that, then we want to return true. Otherwise, if it is, then we call parse binary, which we'll get into tomorrow, which basically represents binary expressions for parsing arithmetic expressions. So, as per usual, let's see how all of this stuff looks on the back end. All right, so apparently I'm an idiot. I forgot to mention that when you parse a dictionary expression, even though we have the code where we are like, allowing stuff to be in here, I forgot to add the part where we allow nothing to be in there. So, of course, we are checking to see if the next token is not equal to a colon, because if it is equal to a colon, that means that there's nothing in the dictionary. If that's the case, then we just want to have an else clause here where we just expect the colon and we end our dictionary. So I completely forgot that, but now let's look to see how everything looks. So if we scroll back up to the top here, we can see we have our here. Okay, so we have our block, we have our statement, our variable declaration, and it's going to be an expression of a dictionary array. So we're going to have multiple expressions. So we're going to have a dictionary array, and then we're going to have a vector array, so we can see both of them. So we have our dictionary array, we have our dictionary type of AST U type, which we're going to have two U types. So we're going to have a type of an int, which is the first U type, and a type of a string, which is the second U type. That looks to be all good. And then after that, we have our, well, we have nothing pretty much because this dictionary doesn't have anything. But if we look at the second statement, we can see here we have our variable declaration, we have our vector array, and we have an expression of AST underscore vector E, vector array, and we have three expressions, which makes sense because we have three numbers here. So we have our first expression of 100, we have our second expression of 120, and our final expression of 1003. So that looks to be pretty good. And yeah, so let's look at the case where we have like our 200 and hello. So if we run that, you can see what the output would be for specifically when you have data in our dictionary. So we have dictionary, we have our dictionary array, dictionary type. So we have our two U types here of int string. Then we have an AST of unknown. Okay, crap, I forgot to add that. This is basically a dictionary element which contains two ASTs, which makes sense. Uh, so we have a expression here, which is going to be the first AST of 200, and then we have an AST expression of literal, of a string literal of hello. So that makes sense. I forgot to mention this, but whenever you're adding new ASTs, just remember to add them or update the toString function in the AST class. So I'm going to go here, go to toString, and I'm going to do a search for AST dictionary. We have dictionary type, and I'm going to put AST dictionary elements. Dictionary elements, copy, paste. There we go. Now let's just run this one more time just to make sure that it is in fact dictionary element. Let's see. All right, so we have our dictionary element, so everything looks to be good. So that's going to be it for today, guys. As usual, if you guys have any questions, definitely put them in the comments section below. And as per usual, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcd/sharp. When you guys get there, definitely watch, start, and fork the repository. It's going to give this language a lot more visibility and let other developers know this language exists. Also, if you guys are curious about maybe things that I do on a daily basis in terms of updates, so on and so forth, check out the remastered branch. Anything other than these two branches here are not used, so keep that in mind, master and remastered. And when you guys get there, you can check out the commits. I write some pretty wordy commits, and they're pretty descriptive, so you can kind of get a gist of what I've been up to just by looking at the commits themselves. Otherwise, if you're a little bit more curious, you can of course go and check out the code changes. Also, if you guys are curious about maybe learning stuff that I've done in the past to the language, or maybe stuff that I'm looking to add into the future, you can check out the docs folder, and you can check out, I have two main files. So I have the changeless file, which basically contains everything that I've done to the language thus far in terms of like updates, bug fixes, so on and so forth. And these are all past changes. Otherwise, if you're curious about maybe not only past changes that I've done, but also things that I'm looking to add in the future, you can check out the roadmap file. Highly recommend you checking this one out. It's very interesting. Gives you tons of insight in terms of the language and what features that the language will actually be having, as well as some of the things that we'll be learning in this YouTube series. So that's going to be it for today, guys. As always, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.